And just you run downstairs.
Mhm.
Okay. Alrighty. Well, thank you all for coming out tonight. Really appreciate it. Welcome to the annual water roundtable. I'm pretty excited tonight. We've got Justin Louen here from the National Weather Service. He can give more of an introduction to himself when he gets up and does his presentation. But we want to just kind of get a weather/water outlook for the season. We're going to be hearing from the Bessemer ditch a little bit later after Justin's presentation. And so with that, please take it away.
Yeah, as Christy mentioned, my name is Justin Louen, and I fulfill a pretty unique role within the National Weather Service. I'm a service hydrologist. And so locally at the weather forecast office here in Pueblo, I, as you can imagine, work with a lot of weather forecasters and meteorologists. So I'm kind of the odd man out, so to speak, and kind of fulfill that sort of niche role where my specific job is more focused on the day-to-day monitoring and warning operations for all hydro or hydrologic related hazards. So that includes warning operations for river flooding, flash flooding, post wildfire, debris flow type threats and that sort of thing. But fortunately, being in this part of the country, we don't typically deal with these hydrologic hazards too frequently, fortunately, or if we do, they tend to be somewhat seasonal in nature. So I do also spend an equal amount of time kind of on the flip side of the spectrum, issues related to there not being enough water, as it pertains to drought outlooks and conditions, and then future kind of water supply forecasts, and then keeping tabs on snowpack trends too throughout the winter period and how that translates to snowmelt runoff too that ends up in our reservoirs for future water supplies in that nature. So today I was just going to give a pretty good overview of kind of what's been transpiring over the last 7 months or so since the beginning of the water year on October 1st up until now, and then just kind of setting the stage for kind of where things stand, and then from there kind of moving at least 3 months into the future, kind of towards the middle of the summer time frame, and then from there too, just to kind of provide us maybe a slightly longer outlook from there. I'll preface this presentation by saying it's not probably the rosiest of outlooks in general, and a lot of what I'm going to share probably isn't a whole huge surprise to any of you, just given how dry it's been over the last 6 months or more, and but there is like a slight glimmer of hope that I'll kind of finish the presentation on, at least, that they give us just a slight bit of hope moving forward into the dry season. And so looking at, precipitation trends from the start of the water year, again, that, starts on October 1st. This figure here on the right shows the percent of normal precipitation starting up from October 1st all the way up until the 27th yesterday. And so looking at the state of Colorado, the warmer colors here on the map, oranges and reds, of course, show well below precipitation, whereas these cooler blues and purple colors show above normal precipitation. And so when you kind of take this like kind of bigger picture look over the last like 7 months or so, you'll notice pretty clearly that the western 2/3 of the state are definitely exhibited below normal precipitation conditions. And then somewhat surprisingly, even when I looked at this image for the first time today, or the most updated one, I should say, out on our eastern plains, and especially from the southeastern corner of the state, we've actually, in terms of like total water year precipitation, actually, looking pretty good. And if you kind of viewed it again at this kind of larger scale picture, you would think, the plains aren't doing so bad, just kind of given these trends here. But a lot of that above normal precipitation for the eastern plains was largely due to some bigger storm events that fell later in the fall and early in the winter time. Because then when you look at the percent of normal precipitation starting from January 1st to now, It's a completely different picture, especially for the southeastern plains here of the state. To where, especially the whole southern half of Colorado is looking, well below normal in terms of, the precipitation that's fallen compared to what, would be considered normal for the season. And so in addition to, these well below normal precipitation patterns that we've seen throughout the state, temperatures and drought indices are also mostly above normal throughout the state too. And so over the last 60 days or last 2 months, the image on the left here kind of shows the departure from normal temperatures. So again, mostly well above normal temperatures over the last 2 months. And then looking at specifically at the standardized precipitation and evapotranspiration index indices, this kind of takes into account both temperature trends and precipitation trends. Again, we're looking at, mostly kind of below normal or more favorable conditions that are conducive for drought, that sort of thing, especially as we look through the Arkansas River Valley, even the upper Arkansas and down to the lower valley to the Kansas state line there. And so, those temperature and precipitation trends, of course, are clearly reflected here in our mountain snowpack conditions. And so for those of you that aren't familiar with the NRCS and their snowpack kind of trend figures right here, it basically just shows how kind of that evolution of how the snowpack forms, beginning in November and builds until, the typical peak sometime in early to mid-April, depending on where you are in the state. And then how that snowpack tends to melt out, starting, early to mid-April typically, and sometimes into July in some years. And so this lime green trend line here kind of reflects what would be considered normal based on the previous 30 years of observations and data. You'll notice this blue line, this is kind of like the maximum or best observed year, which is pretty significant compared to the 30-year kind of average or median. And then you also have the red line here, which represents the lowest snowpack on record. And so this figure here is showing snowpack trends collectively for the entire Arkansas River Basin here in southeast Colorado. Yeah.
Is that black line where we are now?
Correct. Yep. Yep. So this is for water year 2025. So starting in early November, and kind of, does this have a laser on it?
It does. Doesn't show very good on the TV, but
Okay.
That's the middle button.
Oh, yeah. Okay. That's no problem. So kind of going back to those longer term precipitation trends that we were showing earlier, early in the season, we actually had a couple pretty large snow events. And for many of you probably recall that one big storm we had in November here on the plains, especially. And so you can see the snowpack levels responding pretty nicely, right up into that kind of trending with that, whichever water year this was that had showed the max kind of snowpack here. And we had a few, kind of bigger events too, and trending pretty nicely all the way up until right around the new year, where we were sitting right at normal. And then from there, the taps kind of more or less shut off, and just kind of had this, building the snowpack, but just kind of plateauing, and then wound up peaking just, slightly, kind of earlier than normal towards the early April. And then from there, we've really seen, just kind of an earlier onset of snow melt and a much more rapid rate of that snow melt too. And so again, this figure here just shows the whole Arkansas River Basin here in Colorado collectively. So that includes the Central Mountains and the Upper Arkansas Valley, and then in addition to the Southern Sangres. And so this graph, though, doesn't tell the whole story, because as we've observed throughout the water year so far, snowpack conditions really have varied from north to south here in Colorado. The northern half of the state has actually been trending pretty close to normal in general, but then as you move southward, the conditions degrade. That's been kind of exhibiting that trend throughout the whole water year so far. And it's the same deal here in the Arkansas River Basin, here on the east slope of the Southern Sangres. So the figure on the left shows snowpack trends for the Purgatory watershed, and then the figure here on the right shows the snowpack trend for the combined Cotcharas-Huerfano watershed. And we're looking at well below normal snowpack in general throughout the year. Again, peaking a lot earlier than normal, a lot lower than normal, and then snowmelt initiating, almost at the beginning of March, which is little scary. And again, that snow melt or snowpack is melting off quite a bit faster. And as it stands as of today, we're only sitting at about 7% of normal snow water equivalent, as compared to what it typically would be, for the end of April. But then on the flip side, at least, in the upper headwaters of the Arkansas River Basin, again, kind of as we go northward, and then kind of like closer to that dividing line between northern and southern Colorado. For the most part, we did at least see like a pretty normal trend in snowpack accumulation throughout that winter period. But then one of the most striking things that has not only been occurring here in this part of the state, but elsewhere, especially throughout all of southern Colorado, is again that snowpack peaking earlier than normal and then just really rapidly melting off and declining much faster than normal. And so, one of the main kind of variables that comes to mind or explanations for why, snowpack tends to melt out sooner than normal, it's largely attributed to temperature anomalies or departures from normal. And so, again, going back to those warmer than normal temperatures we've been observing lately too, especially in the higher terrain. But one of
those snowpack graphs, they're 30-year averages, right?
Correct, yeah.
Is there a shifting baseline sort of going on where we string together more and more dry years and more warm years, so it looks, it's drier than average, and also our average is getting drier?
Yeah, so we operate both NRCS and National Weather Service, and I would imagine a lot of other land management agencies. We operate on kind of, it's a shifting 30-year window.
Right.
So every 10 years, we update those 30-year averages and we incorporate the most recent 10 years of data, and then we lop off the oldest 10 years.
Yeah.
If that makes sense. Yeah. So yeah.
But when you do that, are our averages getting drier?
Yeah, that's a good question. So I want to say in 2020 was the last kind of update of our 30-year normals. And yeah, so we do it at the start of each decade. And so that was a consistent finding here, at least in Colorado. The NRCS, I recall reporting specific to snowpack conditions, but they did see that those averages, were kind of shifting downward in general. Yeah.
Do you run a tally of, like, say, what it is today versus what it was like, say, in 2002 was a really severe drought? How do we?
Yeah, that's a good question. I don't know the answer off the top of my head, but fortunately, I rely on the NRCS and their snowpack graphics a lot. For those of you that don't know, the NRCS operates those SNOTEL snow gauges in the mountains and all throughout the western U.S. And so, and they have long-term climate or snowpack records too to compare against. And so, I'm not sure if I have a link to this webpage at the end of the presentation here, but I could certainly provide you or the group with one too. But the one nice thing when you pull up these graphics for any particular watershed or basin you're interested in, you can actually click on and off all the previous 29 years individually, and then they'll actually plot on here, so you can kind of get a sense for how they compare to current levels. Yeah, it's a really cool tool. And so, warmer than normal temperatures, of course, are just going to be a natural driver for the earlier onset and snow melt. But one really kind of like interesting thing specific to the temperatures, and I was kind of doing a little bit of a deeper dive on, and this is just kind of like a trend I've noticed over the last number of years when I've been keeping tabs on snowpack levels and then how that translates to river levels downstream during that snowmelt runoff period, is that we're not only dealing with warmer daytime temperatures in a lot of these cases, but we're actually dealing with warmer overnight temperatures as well. And so I kind of have this section of the state highlighted, which represents or includes the upper Arkansas headwaters that we were looking at with that last figure. So typically during the snowmelt period, when snowmelt initiates in early to mid-April, over that first half of the snowmelt period, especially through like middle of May to end of May, more often than not, especially in the higher country, you still get colder nighttime temperatures, and oftentimes they still dip below freezing. And so what that does is it essentially kind of pumps the brakes on the daily kind of like snowmelt in general. And so if you look at a river gauge down in the valley, that's kind of collecting a lot of this runoff. You'll see these natural or daily diurnal fluctuations where, towards the end of the day, snow melts at its peak when the temperatures, are warmest during the afternoon hours, but then they kind of naturally, things slow down overnight once it cools, and it just kind of does that daily cycle. But, over the past month or so, just kind of looking at these like overnight temperature trends, we're looking at well above normal nighttime temperatures as well. So we're not getting that kind of diurnal sort of slowdown or pumping of the brakes with the snowmelt, which could very well be driving, that more rapid snowmelt response we're seeing, in addition to the warmer daytime temperatures, and even possible dust on snow events. Dust on snow has been kind of a phenomenon that's been observed more and more over the last number of years, particularly down in southwest Colorado, but it is starting to be more notable or in the along the Continental Divide in the central part of the state as well. And so anytime you get these like kind of warm, windy conditions coming up from the southwest that deposit a lot of dust onto the snowpack, it lowers the albedo rate. The darker snow, of course, can absorb more of that incoming solar radiation, and then that in turn can really accelerate snow melt too, much more faster than normal when the snowpack's not able to reflect that light like it typically can. And so then naturally, as it pertains to snowpack trends, we kind of transition over to our seasonal runoff or water supply forecasts. This is an image here from one of our web pages that shows all of our different seasonal runoff volume forecast points for Southeast Colorado specifically for the Arkansas River Basin. And again, no real surprise. Pretty much every point we have on there is kind of projecting out to be below to well below normal, ranging anywhere from 17 to 64% of normal. And again, those normal is based on the previous 30 years of observations too, just like in the case of the snowpack trends. And so there is still a little bit of a north to south gradient. I mean, it's not like a great outlook anywhere in the basin, but we have oranges and then kind of like the deeper reds, which are kind of even in some cases less than 25%, especially in the Purgatory watershed. One kind of notable outlier is this point here on the Arkansas River above John Martin Reservoir. And I should kind of take a step back and explain a little bit. For those of you that aren't familiar with our water supply or seasonal runoff forecast, we're basically forecasting the entire volume of water that occurs from April to September that flows through individual points along the Arkansas River and its tributaries. And the forecasts themselves are, of course, going to be always in lockstep with the snowpack trends too. So below normal snowpack year tends to translate to kind of below normal runoff projections as well, which makes sense. But in addition to that, we also incorporate soil moisture conditions. And so the combination of soil moisture levels and a bunch of other environmental factors in addition to the snowpack conditions, kind of tells the full story or bigger picture, what's potentially going to kind of happen. And I bring that up because when you look at, drought conditions here for Southeast and South Central Colorado, comparing kind of at the beginning of winter, December 3rd of last year till, now essentially, back in December, we were essentially, pretty much drought free, which is pretty amazing considering kind of how quickly things kind of have degraded since then. And this kind of comparison is just really interesting too, just thinking about how, again, some of those bigger storm systems we had later in the fall and early in the winter actually helped kind of boost up soil moisture levels heading into those colder months. And it's kind of interesting, as comparing how things were in December and then looking at the projections now. These numbers very well could have been a lot worse if it hadn't been for those decent soil moisture levels heading into the winter. So we can, be, I guess, a little thankful for that, that the overall runoff projections aren't even worse than what they are. But again, going back to the temperature and precipitation trends, everything being subpar, is definitely translated into some increased drought conditions and expansion here throughout this part of the state. And so that's kind of where things stand now. Soil moisture levels again, kind of a mixed bag across southeast Colorado. And we are unfortunately kind of trending, again, towards warmer than normal temperatures and below normal precipitation here over the next 3 months. So these two figures are generated every month from our Climate Prediction Center. That's a part of NOAA and the National Weather Service. And so these two figures are showing the May, June, and July, just kind of overall outlook for the whole continental United States. But you can notice in Colorado, we're kind of solidly in that below normal temperature outlook, or above normal, excuse me, and then below normal for precipitation. And so some of the big drivers for this outlook for the next 3 months is the fact that we are still in what's considered like a weak La Nina kind of climate pattern. That's been in place since the end of last fall, or kind of into winter. We did transition into an El Nino type of weather pattern for a real brief, period, kind of towards the end of last summer and into the fall, and then it's quickly switched back to a more of a weaker La Nina type of setup, which is still currently in place. And typically, anytime we're under a La Nina type of weather pattern, that tends to translate into warmer and drier conditions for southern Colorado. And then on the flip side, the northern half of the state tends to, be on the wetter side than normal. And so that's been clearly evident in the statewide kind of snowpack trends as well, kind of like I was mentioning earlier, how that conditions been more normal or favorable to the north and degraded as we've moved southward. We are starting to see some sea surface temperatures warming though in the eastern Pacific, and that often kind of precedes or starts to signal a transition into what we refer to as ENSO neutral conditions. So ENSO neutral is basically that period of time in between either a La Nina or El Nino type of weather pattern. And the amount of time that neutral conditions can last, it varies. Like I was mentioning just a little bit ago, we did wind up in a brief El Nino pattern towards the end of last summer. But then we quickly switched back to a weak La Nina, so it varies every time. It's kind of hard to say how long neutral conditions would last for. Where our Climate Prediction Centers kind of calling for around a 62% chance of those kind of more neutral conditions. So transitioning away from a La Nina by the early to middle of summer. And so, when we're in like kind of a solidly La Nina or an El Nino type of setup, the climate outlook tends to be a little bit more clear, especially for us in southern Colorado. But then when we're in that neutral period, things are a little bit unpredictable, or just not as certain as to, whether or not we're going to have a warmer versus a drier signal, or vice versa. And so kind of one last thing to touch on, which could, potentially offer, a slight glimmer of hope, I guess, despite all of the really depressing stuff I was just presenting on. Again, transitioning potentially into a more kind of like neutral conditions, especially by the middle of summer, that that coincides with our typical start to our monsoon season here in southern Colorado, which, is all of you probably know, is a pretty good precipitation making, weather phenomena that occurs here every year for this part of the state, especially on our eastern plains. And so we have another oscillation or climate pattern that occurs over the eastern Pacific. It's called the Madden-Julian oscillation. And as a hydrologist, I'm not super well versed in some of these different climate patterns and teleconnections that are out there that people analyze. But basically this MJO is kind of what we refer to it in short. it's a type of weather pattern that fluctuates a lot more regularly and under a shorter kind of time frame than the La Nina, El Nino type of cycles. And so you can have this MJO kind of fluctuating on a weekly basis, kind of going back and forth. And then it usually kind of resets or starts the cycle within 30 to 60 days, whereas like a La Nina or El Nino can last for months or even, upwards of a year or more in some cases. And so essentially, when we have some climate scientists, people in the agency that really hone in on all these different climate patterns over the equatorial Pacific, and there's probably a good 20 or more, but the MJO and the ENSO ones are kind of like our bigger ones that a lot of people hone in on. And so the combination of how those two kind of come together oftentimes can kind of translate or help us predict what's going to essentially be coming our way for the Western US especially. Yeah.
Okay, this MJO, is that the blue line with the arrows through it?
No, so this figure, the blue line here just shows the jet stream,
That
kind
is
of how
the
it's
jet stream.
situated. Yeah. So the MJO is not really depicted here on this graphic. This is just kind of a general kind of weather pattern set up for what causes or what's kind of observed during the monsoon season in general.
So the monsoon season's about a month early?
No, so I was just one of my coworkers, his name's Kyle Mosley. I have his contact information here on the last slide. He's one of those kind of teleconnection gurus that does a lot of really like in-depth analysis on this kind of stuff. And he's been able to actually kind of provide some kind of 1 month precipitation outlooks for our part of the state with some pretty good skill. And he has like a whole distribution list of different partners of ours, both federal, state, and local partners. And so if anyone here is interested, I can definitely share you his contact information here at the end to get on that list. But so in talking with him today, because now we're kind of close enough to that typical start of the monsoon season in early to mid-July that we can kind of get a little bit more of like a decent outlook on perhaps what's to come. And he's giving it about a 50-50 chance for like what would be like a normal monsoon season for us. So that's something, especially in light of just the really bleak way things have been trending over the last 6 months or so. And again, partly it's due to the fact that we are transitioning out of that weak La Nina to those neutral conditions. And then the MJO, just within the last few weeks, has gotten more active. And so typically the MJO is a big driver in monsoonal activity for the Southwest and our part of the country. And it's especially heightened anytime we're in those kind of more neutral ENSO conditions. So with that said, with the combination, he's anticipating kind of like a July 9th for a start date for the monsoon season this year, which is kind of, again, kind of near normal timing wise. And yeah, so, and things on a maybe slightly positive note, perhaps, or hopeful note, but these are a couple of resource links at the top half of the slide here for some of those different images and figures that you can refer to be able to even look up other time periods too, if you're interested. And then I have my email here, and then Kyle Mosley, my coworker I mentioned, if anyone's interested in learning a little bit more about some of the climate teleconnection kind of analyses and outlooks that he does, yeah, feel free to contact him. And with that, I guess I'll open up to any questions.
So given you have, you're using 30-year periods for trends, how long have you been doing these forecasts from the National Weather Service?
Yeah, so are you referring to any forecasts specifically, like kind of more temperature outlooks and?
Well, my interest is, I have a friend of mine used to do quite a bit of statistical analysis on runoff.
Okay.
And people groups like the crop insurance programs were very interested in those kind of numbers. And so I'm wondering, why they weren't how long you've been doing it, why they weren't turning to the National Weather Service rather than to the agency that I was connected with.
Yeah. Was it the NRCS perhaps that you were?
I think that it
The
seemed like the
forecast.
real driver for the need was the crop insurance programs.
Right.
Uh,
Yeah, so to my knowledge, so the NRCS, as an agency, they actually put out those monthly, runoff forecasts in the same manner that we do. And they've been doing it for quite a long time. I can't tell you how many decades or years even. The National Weather Service, we've probably consistently been providing these runoff forecasts for probably the last 20 years, but it really hasn't been until probably the most recent 10 years when we've really kind of ramped up and improved our capabilities. We used to rely like solely on statistical regression methods, which was what the NRCS did for the
And
longest
that's
time
what
as well.
They were doing there, a lot of different
Yeah.
variables, but basically regressions.
And so as an agency, our bread and butter was always kind of more in like the flood forecasting kind of side of things with regards to hydrologic modeling and that type of work. And so we developed a hydrologic model that started incorporating soil moisture conditions and all these other variables that influence or helps translate rainfall into runoff, that sort of thing. And so yeah, probably about 10 or 15 years ago, we kind of came to the realization that, hey, we can leverage this model, and especially with regards to modeling soil moisture levels, and then we can actually use this to project out what those seasonal runoff volumes will be, as opposed to the statistical, regression techniques. So a little bit more robust, we're able to add a lot more data and input into the models too. Naturally, being a weather agency, we collect a lot of precipitation and temperature data, and we forecast for it, X number of days into the future too. So.
And another variable that's in there that isn't in the work you're doing, it doesn't appear, is the reservoir levels.
Right.
Last year was climatically dry, but we had good reservoir storage.
Right.
As a result, it was a good irrigation season.
Yeah. And so I kind of forgot to touch on that a little when I was showing the water supply outlooks, but our seasonal runoff forecasts are actually what we consider to be like naturalized volumes. And so we naturalize those projections by taking all of the available diversions we have out there, changes in reservoir storage, and we add them back in. And so again, it would be like the runoff you would expect to receive at a given point if we took out the human influence, basically. And so that way, that allows us to better translate or relate those projections back to environmental conditions, including, natural environmental conditions, I should say, climate, snowpack, and then to be able to kind of standardize those forecasts to compare against previous years as well. So those runoff values and thousands of acre feet won't actually be realized, of course, because a lot of that water does get diverted or stored in reservoirs. But yeah, it's an interesting point you brought up though too about water availability versus kind of what would be a sort of naturally available, because in talking with the U.S. Bureau of Reclamation folks for the Arkansas Frying Pan project, they made it seem like, even like Lake Pueblo is actually like pretty darn full, and they don't anticipate there being any issues as far as like delivering water downstream during the dry season, despite the fact that we have below normal runoff projections.
Snowpack's gone.
Yeah. So in a way, it's like weirdly enough, it's actually the below normal snowpack's actually a good problem for them, because they're not going to have to do any kind of emergency releases out of the reservoir. But that's for this growing season and for this year. So going forward into like next year, don't know how things will look at that point, but. Any last questions? Or? Cool. Yeah.
Leave it. Thank you so much, Justin. Really appreciate that presentation. Next up, we've got Bret Sabot from the Bessemer ditch, just to give us a little update on what the irrigation, what the irrigation year is gonna look like. So thanks for being on.
Thank you. I'm Bret Sabot. I'm the superintendent of the Bessemer Ditch Company. This year, as far as the irrigation season goes, we've bought a lot of lease water. Just the lease water was available now. I don't know what it's gonna look like in the future, but we've got about 7,500 acre feet of lease water, 7,000 acre feet of winter water. The project water, the frying pan water, they haven't really come out with a number on that yet. So I guess it's looking like it's gonna be, I don't know how to word it, like a decent year. We'll have we'll be running what we call a continuous ditch where all the head gates are open for most of the summer, but it'll be a very small continuous ditch. Compared to last year where we had a very large continuous ditch for most of the summer. So it's not bleak or terrible. It's just gonna be, I don't know, a little below average. It'll be all right. And then I don't have a lot of report on the water side of it, but that's what it's looking like for us.
You guys have any projects going on that you're?
The only projects, like this is the Pueblo County Extension Office, right? Yeah, so the project that the county is looking at is they're trying to build a walk trail on the mesa there by Aspen Road up to 25th Lane. It's kind of like just a public walk trail for people to walk or jog or whatever on that.
On the ditch?
Yes.
Which direction?
It's gonna go from Aspen Road up to 25th Lane. It's gonna cross the ditch in a couple different spots with existing bridges and make us, I don't even know if it's gonna make a circle yet. I guess there's a big plan with this trail that's gonna connect all over the mesa, I guess, is the hope anyway. But they've been talking to us about that. And we don't have a problem with it at the moment, so we're cooperating with it. And as far as everything else, we did a few small projects trying to keep more water in the ditch over the winter, kind of prevent seepage and stuff, but I'm hoping for kind of a quiet year, I guess. It's my first year in this position, so I'm hoping it's just kind of quiet.
Are they looking at doing any cementing of the ditch?
We've looked into getting bids for not necessarily cement, but like a rubber liner and stuff to kind of keep the water in, but it's just terribly expensive. We got a bid for a spot. I think it was about 2,000 foot long of a rubber liner. A little over a quarter mile, less than a half, but it was $800,000 to
A lot of ditch.
yeah, and there's like roughly 38 miles of ditch, so this, almost $1 million for a little over a quarter mile is not conducive to anything, so I don't know. And then we've just we had some engineers come and they're going to give us a ditch assessment or evaluation, kind of point us out to the worst spot or the spots that need fixing, the spots that don't, and hopefully that will help us in the future to receive some grant funding or something like that to keep improving the ditch. I think my big want is to start improving stuff rather than just running it. And you got to put money and fix stuff to keep it going. And unfortunately that's what it's going to take, and everything's just more expensive now. So that's about all I got.
Do you know what the ditch is gonna do in the next couple of days, or you still?
Yeah, we're gonna go the 30th, which is Wednesday. We're gonna go back to a rotating ditch at 100 foot. I forgot to send that email out this morning to the board members, but I'll get that first thing. So the people you have letting you know what we're doing, we'll get that information out to you.
What kind of crystal ball do you work with?
For this year?
Yeah, well, I'm not just this year, but in terms of, for instance, the purchase of the water rights by the city of Pueblo.
Oh, we got time on that.
Is that something that's
The first purchase, I think, was, no, this is way before my time. But the first purchase was a 20-year lease, I believe, and we're coming up on that 20 years. And then the next purchase, or the next lease is, as far as I know, they're going forward with it. I can't remember if it's 10 years or 15 years. And it might be a little more expensive, but, so there's another 10, 15 years easy on that. And then the Board of Waterworks is not short for water. So they don't need the water that they purchased. So I would say 30 years before we even start worrying about them pulling their water out. I don't see that being an issue for a very long time on that. Anything else? All right.
Thanks very much. I was hoping we'd have the ditch writer from Oxford Farmers Ditch, but he wasn't able to make it here this evening, so that pretty much wraps up what we've got for this evening, unless you guys have any other questions or want to have any more in-depth discussion. I had some handouts here that have got some different bills and whatnot that are associated with water. I think the biggest one is the federal WOTUS thing that's coming through, so just kind of keeping an eye on that. Obviously CSU doesn't take a stance one way or another on these things, just mostly want to get the information out to you all so you can make your own decisions on that. But other than that, if you guys have any other questions, feel free to grab some snacks or chat or any other questions or discussion. Good to go. Cool. All right. Thank you.
Thank you. Thanks.
What?